parallel lines and perpendicular lines, and we were talking about how we find the equation of the line and whatnot on the other, right? And then the computer chose to stick, and that was just the end of the session. So, yeah. Anyway, today what we're gonna do is just like look back at that, make sure that everybody's on the same page, and then we're going to do some inequalities, because you all would have met inequalities at Form 2 level, right? You all know what inequalities are, what they look like,
I
kind of.
think so.
I think so. Trust me, when you see it, you might know what it is. And yeah, we need to know how to represent inequalities on a graph. So let's hop into it today. So I heard Form 3 Parents Day is on February 8th. So,
That's only good things, right? No? Only good things.
hmm. Only good things. To be honest, like I know parents don't really like to have to go from teacher to teacher whole day. So I might prioritize like certain students who I think I need to talk to the parents just to find out what's going on, make sure everybody alright, that kind of thing. But if you all wish to like come in and, quote unquote, meet with me, that's not a problem. Alright. But the ones that I want to see, I might put them like as priority, and all the good things, yes, I wouldn't really have too much complaints. To be honest, I don't have complaints. I just have like, for me it would be concerns, like if they need any extra like guidance, that kind of thing. If they having issues at home in terms of like internet connection, device access, those kinds of things, because honestly, I don't see the point with like, what's the point of being like, oh god, your child don't do nothing and your child is I don't see that. I don't see that happening, because most of y'all, you do work and stuff. For the people who do their work and they might want some like extra help, they know how to message and will ask for the help and show me what they're doing, that kind of thing. And even like, yeah, even the ones who probably would think that they're not engaged in class fully and whatnot, um give and take with the fact that we're dealing with online environment. um just like in a normal class, some people might be more vocal than others. So I'm not going to beat up too much on how much people talking, like actually volunteering and whatever. But the important things for me would be whether or not you have the right set of things to get access to classes fully, and in terms of where you all are at with coping with your work. Because realistically, if one of my form was like, I was wondering why I hadn't seen her for the term, I messaged her. And even last term, like I know at a point in time I had her, so I was wondering like why she dropped off. So I messaged her to talk to her, and she said, to be honest, she was struggling with school. She just felt really, really overwhelmed. So this is why, like, even for the people who probably might come in, they don't necessarily engage. Sometimes they do their assignments, sometimes they don't. For me, it's more concern of like, how are they managing? Because if you're not managing, whether or not you understand what you're doing, you're just not gonna be able to do everything to the best of your ability. So that's why, like, when it comes down to grades and thing, I try not to like put too much emphasis on quote unquote good grades. To me, it's more a reflection. Your grade is more a reflection of how well you understood the concept for that term in order to be able to apply it. So it's not like somebody who gets a, a C, they terrible at maths, and they how to put it, like they're just not in class and they're not paying attention. Because I'm sure there's some of you who might say, well, I attend every single session and I do every single thing and I follow up on every single thing, and then when you come down to the test, you've kind of black out in a sense that you don't know how to do things or you forget. So that's why I try not to stress too much on getting quote unquote good grades. It's more about you as a student developing certain skills and expanding your knowledge. All right. So last week, like I was just telling myself, when the computer stick, it was like, what's supposed to do now? And when you all started to, exchange how you all were working out your problems, that was one of the good things about that particular opportunity that day. You all took the opportunity to help one another. And this is also something that, like, since last time I was saying as well too, you could create with, like, within your own little circles, a study group to help yourselves and support one another. So that way you don't have any issues where somebody lagging behind and they feeling kind of shamed to say, well, they do understand something, right?
Yes,
The next thing,
we do have a study group.
see, and this is the next thing that I was gonna say. There's some year groups, some classes, they don't think to do things like that, and that is really good that you took the initiative to set up a study group so you could help one another. That is important. Teamwork is important to actually be successful, and especially to get through school. It is good to have a very good support network, right? So that's admirable that you will have been putting yourselves together like that. That will take you through this entire journey and beyond, and you all will have greater success together as a team. All right. So, Parents' Day, I don't really have any big complaints per se. It's more, concerns. And yeah, with respect to all the wonderful things that happened last week with my PC sticking, the PowerPoint, just in case, people were feeling like, what going on, they don't know what going on kind of thing. Um, the PowerPoint, just, let's see, where is it? Right. The PowerPoint in our files area. You go in there, you look for coordinate geometry, it's in class materials. You'll find this particular PowerPoint. And this was something that was started since last term. So you'll have everything from the beginning straight till the end, right? And the part that I actually want to go to, just give me a second. The part that I want to go to would have been the one with the equations and how we obtain the equation of a straight line. So sometimes you might be given a line segment and you would have to find the equation of the straight line. In a case like that, you need to know that you have to get your gradient of the line segment, and also you just have to use a point on the line. So for these types in particular, it's actually easy to find where the y-intercept is, since the line segment here would have cut the y-axis. So if I had to find the equation of the straight line, it was just a matter of find the gradient, read off the y-intercept, and put it all together in the form y is equal to mx plus c. All right, so for this one, when we found the gradient of the line, we got that the gradient was 2. And when we looked at the line segment, we could tell that the y-intercept was at -2. So that's how we would get this equation, y is equal to 2x minus 2. Now, realistically, all problems would not come as nice and smooth and simple as this. You would get just information and you need to know how to obtain the equation of the straight line. But all of the things tying to the equation of the straight line come back to the main part of it, which is knowing the general straight line equation form being y is equal to mx plus c. So yesterday I had shared a good few links. You don't need to go explore all, but you could just pick whichever ones work best for you. The very, very first one, that link would go over everything about the equation of the straight line. And what I liked about that particular site is that it listed all the different versions of the general straight line equation around the world, because everybody has a different way of referring to things. And I do recall when we began doing the equations, somebody had asked this question about, well, the site, I believe it was, they used y is equal to mx plus b rather than us accustomed to using c. And the reason for that is that, like, everybody decides to call the y-intercept something different. So we use the UK format, which is the y is equal to mx plus c. The American format, I believe, is the y is equal to mx plus b. Then if we go all the way to Japan, Japan would say y is equal to mx plus d. So every region where they represent the straight line equation differently, they listed it out. Not that you need to know all the different formats, but it was just like actually quite an interesting extra bit of knowledge. Like, hey, everybody in the world are a little different, you know? And the Greeks, I believe, is psi is equal to what was it? Wait, I don't recall the full thing, but when I looked at it, I was like, down to the Greeks, they have a different thing. Everybody have a different thing. So yeah, straight line equation. Once you know the general format of it and you understand what m is and what c is, you will know how to obtain your equation of the straight line. And like I was saying, what I loved about last week, out of a technical difficulty, arose a really wonderful opportunity for you to share your knowledge. And we got some really good questions in as well. So some people were asking things like, okay, so why don't I plug in values for y and x? So you'll notice here, like y is equal to 2x minus 2. Y and x don't ever have to have values when you state a straight line equation, simply because this straight line equation is actually the relationship for the x values and the y values on this line. And that's exactly what the equation is. It's a relationship. It's a relationship between two variables. So that's why when we state our straight line equation always has the variables x and y included just as they are, and the only numerical values would be things like our gradient and our y-intercept. Okay, so sometimes the equation would not look like this. You would see things like fractions involved. Sometimes to get rid of the fractions, they would have things like 2y is equal to x minus 5, and you need to know at that point in time how to transpose your equation if you want to get things like the gradient of the line and you want to get your y-intercept. So last week during the Thursday extra session, I was showing those who had came in this particular game, and within that game it was testing things like your ability to transpose equations. So if they give you a straight line equation that is not looking like the form y is equal to mx plus c, like this one, you have to know how to transpose it so you can get things like the gradient from it. You can get things like y-intercept from it. It was also testing that general bit of knowledge of what is the relationship between the gradients of parallel lines and what is the relationship between gradients of perpendicular lines. And these things are important for us because when we have different problems, they may not ask us about the straight line equation just like this alone. They might ask us for one parallel to it. They might ask us for one that is perpendicular to it. They there may be cases where they will say a line is a perpendicular bisector to another. All right. So before getting to the perpendicular bisector part, right? The important thing that I want you all to remember whenever we deal with straight line equations, the number one thing is you must know the general straight line equation format, which is that y is equal to mx plus c. The next thing is if you want to obtain a straight line equation for any line segment, whether they give you the graph itself or the information about the orientation of the line and where it passes through, you simply need to know.
Excuse me, Miss.
Yeah.
Miss, you're showing something right now. Like
Yeah, a PowerPoint. You're not seeing it?
it just have what the Cartesian plane locating and plotting points and a link. That's what it's showing.
Mine is the equation. So we were looking at the equation. The slope of the line is 2.
Genesis, you see in the PowerPoint?
No, not seeing it. 'Cause I thought Miss was talking because I was wondering what he was talking about. I go and come.
Oh.
I go and need to meet and come back and see if I would see it.
All right, try that and see. But yeah, basically, like I just talking in general now. Like anytime you have to find the equation for any straight line, always remember that you need to know your general straight line equation format. The y is equal to mx plus c. The next thing is you need to know how to use the information they provide for you about the line. So, for instance, if they tell you things like the orientation of the line, a point that it passes through, those sorts of things, you need to know how to use that information. So, in some instances, they may tell you, well, okay, the line is parallel to another line, and they might give you the equation of that line. And that's exactly what we were seeing with some of the problems from last week. So what I want to do now is just give me a second. Okay, it's stick. That is so weird. The PowerPoint was okay, no. Alright, yeah. So here we go. Right. So like I was saying, right? They may just simply give you information about the line itself. So like in this case, notice here they give you points. So if they ask you to get the equation, okay, no problem. So yeah, if they ask you to find the equation of the line segment AB and they give you the points AB, to find the equation of that line segment, what should we do? Any thoughts how we find the equation of a straight line given 2 points? No thoughts? Anybody? Oh, Genesis, as you came back in, you see in the PowerPoint right now?
Yes, Mrs. Yes.
Excuse me,
Yeah, okay. Yes, Talisha?
excuse me. Miss, what are you supposed to be sharing right now?
Oh, Emily. Right now I'm looking at a PowerPoint. So if you all are not seeing the PowerPoint, I would recommend you go into class files.
Miss, the PowerPoint that says general equation of a straight line.
Um, that one is coordinate geometry. Just now, it's supposed to be intro to coordinate geometry. So when you open the PowerPoint, you're going all the way down to.
What's on the screen right now on the call?
Right now I'm on slide 36, which is points on the line segment.
No, Miss, I'm not seeing that.
Miss Einstein can't display content.
Look on top and you'll see it has 33 out of 44 or something, and you could change the arrow to go on whichever slide.
Yeah.
In the call it's about?
Yeah, on the call
Yeah.
itself, on top it has to present a 36 or whatever, and then has the slide numbers and arrows to click which one you want to go on.
I'm not seeing that. I'm using a tablet, so I don't have all the
Miss, is this in files already?
Yes, it is on files.
What's
So
the name it on?
just give me a sec. Here, what I'll do. Just give me a second, right? PowerPoint just gives so much trouble on this sometimes. Okay, so everybody, this is how we're gonna do this stuff to get the PowerPoint, right? So anytime you'll need to get the PowerPoint, we go to Files.
Among Us?
Yeah, I used to play Among Us. I just don't have time to do anything these days. So all I'm doing is work, 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 work. So term 2 notes, coordinate geometry resources, and we're looking at intro to coordinate geometry. So this wonderful little PowerPoint. And you can
Miss,
go, yeah?
excuse me, I was trying to do the equation notes and it was
Uh-huh.
very blurry.
Yeah, the worksheet that I don't know what to say. I had gotten, I have to look for some other ones because I don't know why the quality of those weren't so nice. Normally it's be good, and I don't know. I really don't know. But on this PowerPoint, actually, I did include some stuff for you all. So look over here, right? This particular site, this is how they present the solutions, right? So I might have to share the screen just now. Just let me know if you'll see when I go to, you can see my screen, right?
Yes, Miss. Now say
Alright.
it.
Nice. So on this particular site, they go through parallel and perpendicular lines, and although their formatting for the site is not very pretty and appealing, the information is there, so you can take a look at it, right? So on this particular site, they were using y is equal to mx plus b. So like I said, that's like US. So if you wanted to see some worked examples, they actually explain, what is going on in the example and how you come up with the answer. So let's just take a look at this first one. Okay, so this first one, they said to find the slope of a line that is parallel to the line y is equal to minus 3x plus 4. So like I was saying earlier, we need to know about the property of the gradients between parallel and perpendicular lines, right? So when we look at the straight line equation, once we can identify what is the gradient and we recall the property for gradients of parallel lines, we'll be able to state the gradient of a line that is parallel to this particular equation. So first things first is we know that the straight line equation we're given here is in the form y is equal to minus 3x plus 4, which is y is equal to mx plus c. If we recall, m is our gradient, then we know we just need to look at the numerical value in front of x. So I just want to make sure and highlight this, right? Because up to my form 4s, they sometimes have trouble with distinguishing the coefficient from the coefficient variable product. Always remember the coefficient is what you want when you state things like the value of m, because that is the gradient only. The value of m is our gradient. So that is why we have to know that it's the coefficient, which is this numerical value in front of our variable. So in this case, minus 3 is in front of our variable x. So if I want to state the gradient of this line, I will say that m is equal to minus 3. However, our question was asking us about the slope of a line that is parallel to this particular line. So what is the property for the gradient of parallel lines?
That's what I mean property.
Okay, so when I say property, it's like what is the relationship between the gradients of two lines that are parallel to each other?
They'll be the same.
That's it. That's what I wanted to hear, right? So when I say properties, properties is just like what. Okay, sorry about that. Right. Yeah, the properties. When I talk about properties, I'm just talking about what is the relationship between the lines, right? So when it comes to the gradients of parallel lines, once you can recall that they are the same, if you can find the gradients of, like for instance, in this example, the gradients of the line that we were given, then you can tell that any line that is parallel to y is equal to minus 3x plus 4 is going to be a line that has a gradient of minus 3. So let's just say I decided to ask you whether or not all right, cut that. What if I ask you what is the gradient of a line perpendicular to this line? Y is equal to minus 3x plus 4. What is the gradient of a line perpendicular to y is equal to minus 3x plus 4? The first thing you need to recollect is what is the relationship between the gradients of perpendicular lines, and then use that relationship to tell me what is the gradient. So go ahead.
The gradient will be the product of their gradients is equal to -1.
Excellent. So yes, so that's the first part. So we got started with that one, right? Perpendicular lines, if we take the product of their gradients, we will get -1. So if this line has a gradient of -3, I need to multiply -3 by something so that the product is -1. So what would I multiply -3 by to get a product of -1?
Because we are so small in the
Okay.
Caribbean.
So somebody said 3. Any other thoughts?
Wait, no, Miss, wait. That's the answer. Wait.
Okay. So go ahead and you can work it out. So remember, -3 times something gives me -1.
Miss, would it be so minus 3 over
Uh-huh.
1 multiplied by Miss, yeah, never mind.
Don't worry, it's not as difficult as we think it is. So another way that I usually, well, if I had the writing tool, I would have been able to do this, right? But actually, you know what? I could probably stop sharing for a bit. Give me a second, and I'll come back to the site in a little bit, right? Let's go to the whiteboard. We have this wonderful little tool here. So, yeah, collaborate. Hey! I was working on this at some point in time. Okay, cool. Let's go. So, we have y is equal to minus 3 it's plus 4, right? I think, yeah, I hope so. Let me just take a little quick peek. Yeah, plus 4. Okay, so what is the gradient of the line that is perpendicular to this one? All right, so we said for perpendicular lines, all right, the gradients product would be -1. So this would mean, let's just say that I call this gradient M1, and let's just say the line that it is perpendicular to has a gradient of M2. Okay, so the M1 and the M2 is just so that you know I'm talking about two different lines. Okay, I want to find M2 because M2 is the line that is perpendicular to this one.
Miss, I think I get the answer.
You think you get the answer, right? Okay, cool. I'm gonna just write in the property first, and then you will come and you'll write on the board and put your answer. Okay, so the first thing was M1 by M2 is going to give me -1. Okay, so the product of the gradients of the two lines is minus 1, right? And that's if they're perpendicular. So in this case, if m1 is minus 3, minus 3 by m2, I could write that as this product, okay? Minus 3m2 is equal to minus 1, and then I could solve for m2 from here. So Anya, you could go ahead and write your answer, and then we'll just continue with this particular demonstration to see if that helps people with understanding how to get the gradients, all right? So go ahead.
Just the answer, miss.
Yeah, you can put just the answer if you want to put your work in. You can go ahead. Anything you want to do.
Anya, could you put your working too, please?
Oh yes, I'll mute a little bit. The dogs next door quarreling.
Please don't confirm I'm a drawing, please. Please.
In the Caribbean.
Anya's an artist. Oh my gosh.
Alina.
Felicia, sorry. I can't put my work in. I just know the answer.
She just know the answer. So what's the answer? All right, cool.
1/3.
That's it. So the answer is 1/3, and we're going to see how we get this 1/3. All right. So the relationship, I usually tell people to learn it like this as well, just in case that little piece of having to figure it out by doing it working doesn't really help them, right? Sometimes people get confused with it. But the relationship between the gradients, remember, the product is going to be minus 1, which tells me that one of the gradients will be the negative reciprocal of the other. So I'm going to show you the working so that we could get this 1/3, because this is correct. And hopefully this way might help for the people who need to see some sort of working. And like I was saying, the relationship, one is the negative reciprocal of the other. We will see what that means in case you don't understand it, right? So let's see. I have minus 3m2 is equal to minus 1. So anyway, if I have minus 3 times m2, this is a product. Anybody wants to tell me how I'm going to get the value for m2? I wonder if it was Adina who was singing away.
Miss me, I get the answer.
Yay!
And I was so happy.
So you want to come put it on your board?
mic unmuted. Oh my goodness.
So you can come put your answer on the board. Go right ahead. So when you have to do the working, like I was saying, if you remember that this is a product, minus 3m2 is equal to minus 1, we just need to know how to transpose. So we need to know how to make m2 the subject here. And in making m2 the subject, we will in fact get the 1/3 that Anya had gotten. All right, so what I'll do is divide both sides by negative 3, since I want to solve for m2, and I will get that m2 is equal to 1/3, because this negative 1 over negative 3, negatives will, well, a negative divided by a negative will give me a positive, and that's how I get that m2 is 1/3. All right, so this is correct. All right, the answer is 1/3. Yay! So that's what I was talking about. So like it comes together really well for somebody who loves to see working, needs to see that working, and for others, like I was saying,
Oh,
the
okay,
negative.
misunderstood now.
Right. So the negative reciprocal. Why I was saying negative reciprocal is this. This -1. If we know what the reciprocal is, the reciprocal of a number is just 1 over the number. So let's say we had something like +3. The reciprocal of +3 would be 1/3. All right. But in order for us to get a -1 product, so let's say we were multiplying 3 by 1/3, and we need to get -1. We can't multiply two positives. We actually have to multiply a positive by a negative. So it could be that if we originally had a +3, then that means the one that we multiplied by had to be the negative. So like in this case now, because we have a -3, that's how we know if we take the negative reciprocal of -3, we're going to get the 1/3 that will give us a product of -1. Okay, but like I was saying, if some people the working makes sense for you, work with it. All right, so just to test that everybody understands this fully before we progress, I'm going to erase all the beautiful working that we have here.
Miss, wait.
Miss,
Yes.
Miss, I don't understand, Miss. I really lost.
Okay, which part?
Everything, Miss.
Okay, so we're gonna start back.
Miss, you could just like explain for me stuff again, please.
Okay, so if I ask you all for the gradient of a line that is perpendicular, so I'm just going to use this little shorthand drawing kind of thing, perpendicular. So we know that perpendicular lines, they intersect at a 90-degree angle, right? Now, if they intersect at 90-degree angle, one line is definitely going to have a different gradient from the other, because if we know the relationship between straight lines, we know the ones that are parallel have same gradient because they basically would run equidistant from each other. They don't touch. They have the same orientation. All right. But when it comes to perpendicular lines, they run quote unquote opposite to each other in a sense, right? One is vertical and the other is horizontal. So the gradient of these two lines, they would be different. Now, they actually established a relationship between the gradients of perpendicular lines. And that relationship is that when you take the product of two lines that are perpendicular to each other, so like I was saying, if I represent the gradient of one line as M1, so let's say we call this line L1, and let's say we call this line L2, okay? If I were to write out the straight line equation for each line, so when I say the straight line equation, I'm just going to go with the general y is equal to mx plus c thing. So let's say L1 has equation m1x plus c. And just to denote that the two lines are very different, I'm going to use a different constant to represent the y-intercept for the second line, okay? So let's say L2 now has equation y is equal to m2 x plus k. Okay, so just in case anybody want to know, this is the equation for L1, this is the equation for L2, all right? So like I was saying, I'm dealing with two very different lines, and they have one relationship, which is that they are perpendicular to each other. How did that get there? Okay. So back to what I was going to do. If I know the relationship between perpendicular lines. So for us, we just need to use the relationship. We don't need to know how exactly they established it. The relationship between the gradients of these two lines. So the gradient of M1 and the gradient of M2, if I were to take the product of these two gradients, I would get that M1 by M2 is equal to -1. Okay, so this is a relationship that we're using for perpendicular lines. So anytime they say perpendicular lines, immediately we must recollect that the product of the gradients of two perpendicular lines is -1. So you're following so far?
Yes, miss.
Okay, so once you know this particular relationship, whatever equation they give you, you'll be able to get the gradient 1, but also get the gradient of a line that is perpendicular to it. Okay? Who is the ghost that keep moving around my working? I don't like you. Stop moving around my working. Oh my goodness, let's see if I can move it back. Ha, I move it back. Right. So let's say we're working with the same equation that we had here, all right? So M1, I'm using the first line. M1 is going to be -3, all right? So y is equal to -3x plus 4. If I ask you, what is the gradient of this line? The gradient of this line is -3. So immediately, if I say I want the gradient of a line that is perpendicular, if I want the gradient of a line that is perpendicular to this one, what I'm going to do is recollect this particular relationship. And the relationship is that the product of the gradients of the two lines is going to give me -1. So I have the gradient of my first line, and when I recollect my little relationship here, I plug in what M1 is. So M1 from the equation up here is -3. So that's why, because I know M1 by M2 is a product, that is why in the next line I write -3 M2, because this is understood to be a product. Okay, so I don't know if this is where it started to get confusing for you, but -3 M2 is equal to -1 is basically this, where I just substitute the value of M1 to be -3. Making sense so far?
Yes, miss.
Okay, good. Now the thing is, I don't want -3 M2 equal to -1. I actually want a gradient. I want a value. I want a numerical value. So in order for me to get a numerical value for M2, I need to solve for M2. And like any other straight line equation, just like any other type of algebraic equation, I need to make the thing that I want to solve for the subject. So in this case, -3 M2 equal to -1, I need to know how to make M2 the subject. So like I was pointing out, this is a product. And once I can recognize what is the coefficient of this product, I'll be able to solve for M2, because all I need to do here is divide both sides by my coefficient and we're good to go. So that's why I divide by a -3. So both sides being divided by -3 leaves me with M2 on the left-hand side. And then this -1 over -3, this has everything to do with directed numbers. If I divide two negative numbers, my result is going to be positive, which is why we don't have any minus signs in this answer. And 1 over 3, we could either put 0.33333 recurring for however long if we want, or we can leave it as a fraction, all right? 1/3. So this is how I get my gradient for my line perpendicular to the one that I was given the equation of to be 1/3. So does it make sense how we get the 1/3?
Yes, miss.
All right. So here's what we're going to do, just to, kind of make a nice little full connection. Okay, I see it, Cavell, don't worry. if Cavell could hear. All right. So what I want to do now for everything to come full circle, let's try writing the equation of the line that is perpendicular to this one. So what we'll do is write the general equation before we go on to putting in any y-intercept or any point. Since I didn't have a point, I will just pick an arbitrary point. But first, let's write the general equation that's going to be perpendicular to this one. So if I had to write that equation, I would be writing that y, so you use this, let's say we use this here. All right, this is the general equation. Y is equal to m2x plus the y-intercept, which we represent as k. So y is equal to m2. Our value of m2, we found it to be 1/3 x, and we still don't know our y-intercept as yet, so I'll just put back k. So in doing this piece here, everybody's still with me?
Yes, miss.
Yes? Anybody is lost, doesn't know where this came out from? No. Okay. So I just want to make sure that we all understand
Miss,
how we
actually, could you
progress.
explain how it's why it's there? That is the gradient for the second
Yes.
picture. Okay, okay.
Yeah. So this is the equation for the line that is perpendicular to the one that I was given. So all I'm doing here is just writing a general equation since I now have my gradient.
Miss, why is
And
key?
okay, so I just decided to use k because I want to distinguish it from the other. Yeah. So, oh yeah, just quick point to note, just in case some of you decide to do things like add maths and probably even pure maths and whatnot. Anytime you have arbitrary constants, as in you don't know the value of it, but you know that it should have a value there, you can use any letter to represent it, but you just need to make sure that you define it. So typically, when I write these things out, handwritten, I would indicate that k is a constant, or that k is um, k is the y-intercept of my second line, just so people know what it is. So the reason why I'm telling you that, if you'll go on to do add maths and pure maths and whatnot, where you'll be dealing with a lot of numerical values, a lot of variables, etc., you definitely would want to make sure that you can label and identify all your constants, your unknowns, your variables, values that you find, equations that you construct, all sorts of things. So that's why I'm a very particular person about my notation. Okay, so I make sure to distinguish that two lines have very different gradients and very different y-intercepts by using different constants or by using subscripts. So for this line, let's just say that thank you Ghost, whoever fixed it. Thank you. Anyway, what I was gonna say is this, right? Let's just say that I told you all that this line passes through the point yeah. So let's say this line passes through the point 3, 2. Anybody want to tell me how I'm going to use this point so that I'll get the full equation, so I could get something that resembles this a bit? How am I going to use this point?
Miss,
Substitution.
Substitution.
Numbers.
Yes? So we all agree? Substitute something
Miss, are we
somewhere?
trying to find for k?
Yes, that's exactly
Okay,
what
then,
we
yeah.
need to do.
We're substituting y and x, and then after we multiply x by the gradient.
Mm-hmm. 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 Okay, so everybody understands what she was saying just now, or does anybody want to know exactly what she means by substitute the point? Anybody? Any questions at all? Or is everybody following?
Miss, you can explain it?
Okay, so I'm gonna do the process itself now, right? Now, anytime you need to find the full equation, because we can't just have, okay, well, y is equal to 1/3 x plus k. That doesn't really fully tell me the equation. Okay? When you have a point, so they tell you that the line passes through a specific point, this goes to, Anyway, so they tell you that the line passes through a specific point. You're going to use that point by substituting it into your general equation, and that will help you find k. So in this case, I have the point 3, 2, and 3 is my x coordinate, while 2 is my y coordinate. So in my equation, where I see x, I'm going to plug in the value 3, and where I see y, I'm going to plug in the value 2. So this will give me 2 is equal to 1/3 times 3. And we still don't know k as yet, because essentially what we want to do is solve for k. So I will simplify this now. So 1/3 by 3 will give me what?
1.
1.
1.
So we all agree with the little arithmetic, right? 2 is equal to 1/3 by 3, which is 1, plus k. So how do I solve for my unknown k? How do I get the value of k?
-1 from both sides.
-1 from both sides. We all agree with that?
Yes, miss.
Yeah?
Transpose.
Anybody? Okay, so transpose. So we hear the word transpose, and that should sound familiar to most of us, right?
Yes, miss.
I hear her now, like she erasing something.
Shit.
So normally for me, I like to write my unknown to the left. So even if I write my unknown to the left, I just want to point this out. I am not changing the sign, because even if okay, well, here what I'll do. So I'm gonna write it the normal way first, and then I'll tell you all that part, right? So I'm subtracting 1 from both sides, and that will give me that 2 minus 1 is equal to k. All right, and we'll get that the value of k is 1. Just give me a second. All right, so the value of k is 1. Okay, so I'm just going to erase all this here, because we don't really need these things on this side, right? So the value of so we get the value of k to be 1. 2 minus 1 is k. All right, and like I was about to say, I prefer to write my unknown to the left. So me just putting k is equal to 1. This is the same thing as this, because both sides are the same. All right, they're equal to each other. They're the same. So I could just I just flip them around. It's like I just flipped the whole thing, right? I did not move anybody anywhere. They are both equal to each other. So I just switch the order I wrote it in. Okay, like if I just take the whole equation, just flip it over. Okay, so no, it doesn't need to change signs, and I just want to make sure and emphasize that, just in case people wonder, well, why is not a -1 and why is not a minus k, or all them kind of things. So let's wrap this up, and we're going to put the value of k into our equation. So I'm going to write back my equation, which we have found to be y is equal to 1/3 x plus k, and I'm going to put the value of k as 1. So let me just check and see what Raquel said. Okay, the calls keep getting dropped because I'm not in an area where the connection is stable. All right, no problem. Don't worry. That's why the session is recording, so you will get a little playback for it, right? I usually used to upload the videos, and sometimes I just forget to download and re-upload it so that you'll have it longer than the 20 days thing. Okay. So final thing, we have y is equal to 1/3 x plus 1. Now I just want to highlight, if you dislike fractions and you don't want to see this 1/3 here, you can multiply everything by 3 so that you don't have the denominator anymore. And like I was mentioning earlier, the game that I was using in the Thursday session last week, they would have seen how equations can the equations of straight lines, but it doesn't necessarily have to be in the y equal to mx plus c format. So just to demonstrate, if I multiply everything by 3, I'm multiplying my entire equation, all right? So if I multiply everything by 3, it will be 3y is equal to 1/3 by x, multiplying, plus, right? Multiplying 1/3 x by 3 would leave me with just x, and multiplying 1 by 3 would give me 3. Okay, so essentially every single term in the equation must be multiplied by whatever I said I was multiplying by. So I multiplied everything by 3, and that's how I got 3y is equal to x plus 3. Any questions with that part? Or you'll still absorbing
No,
all of
miss.
it? No questions, right? Nadia? Nada? All right, so we'll leave it, right. So we'll leave it at that with the straight line stuff.
We leaving it as 3y. Wait, miss, that's the final answer with the 3y there?
Right, so that was what I was saying. You could either leave it at y is equal to 1/3 x plus 1, or you could write it as 3y is equal to x plus 3. And the y is equal to 1/3 x plus 1, like I was saying, if you are the type of person you prefer to see it in the y equal to mx plus c form, leave it as it is, don't interfere with it, right? If you're the type of person you don't like fractions and you want to get rid of this denominator, multiply everything by 3, and that's how you get the 3y is equal to x plus 3. All right, so either way is acceptable, but it's up to you to decide which one works better for you. All right, and the reason for just bringing this particular thing into it here, if you all want, I can't recall if I had shared the link for the game or not, but I'll share it. And in that game, you all are going to find that some of these straight line equations, they're given like kind of like these, where y is not the subject. If ever they ask you to find the gradient or the y-intercept of a line and they give you the equation like this, ensure that you make y the subject. So if you have something like 3y is equal to x plus 3, you have to divide everything by 3 so that you'll get the proper gradient and the proper y-intercept. Okay, so I think I will make sure and share that link so you will have something to just like a fun little practice, all right, to go over straight line equations, the property for parallel and perpendicular lines gradients. Okay, so the last thing that I wanted to talk about was inequalities, and that essentially is about it for today. All right, so I'm just gonna erase the, anyway, we have the playback. I was thinking to myself I should have saved the image, but then I realized the ghost, the whiteboard ghost, went and like create some havoc on my board. Okay, so I'm just gonna do a little general sketch here. Let's just say I have, wow, that line real straight. Let's just say I have a Cartesian plane. In the words of every math teacher ever, I am not an artist. Okay, so if my lines don't come out too straight, I'm not a ruler either, so we'll work with that. Okay, so we call this the x-axis, we call this the y-axis, and our origin is over here. Okay, now let's just say I give you all a line like x is equal to 4. All right. I missed my whole point, boy. Wow. Okay, I'll just extend from here. There we go. Okay, so let's say I give you all the line x is equal to 4. So I'm going to put in its equation, x is equal to 4. And I asked you all, well, okay, where is x greater than 4? Would you all be able to tell me where x is greater than 4?
At 5, miss?
At 5, so that's a good start. Exactly, at 5. So x greater than 4. Every number to the right of 4 would be greater than 4. Isn't that correct?
Yes.
Yes.
Excellent. So here's what we're talking about now. We're talking about graphically representing inequalities. So when we talk about inequalities, we just need to understand the concept of the greater than, less than, greater than or equal to, less than or equal to. So if I want to represent an inequality like x is greater than 4, x is greater than 4 everywhere to the right of the line, x is equal to 4. Making sense?
Yes, miss.
Yes, miss.
Okay. So just like we can do x is greater than 4, we could do x is less than 4. We could even use y is greater than 1, y is less than minus 1. We could do absolutely any region that we want on the Cartesian plane. Once we understand the concept of greater than, less than, greater than or equal to, less than or equal to. Now, these aren't the only lines that we will have to look at to see where they are greater than or less than. There are some lines like the straight line equations that we were looking at, for instance. We need to just give a minute. Okay, so my time with earlier, like, it's up. So let me just like I just mentioned in this, we'll see if I find some extra stuff for you all to look at with inequalities, because I know I had shared a link as well yesterday about inequalities for you all to kind of like just do a recap of some things that you all would have done before. But anytime we deal with inequalities, you just need to understand that concept of where greater than and less than, greater than or equal to and less than or equal to would be on the Cartesian plane. Okay, so just a quick illustration of another type of line that they may ask you for for representation for an inequality. Let's say I had the line y is equal to x. Okay, y is equal to x. And let's say they asked me to represent the region where y is less than x. Now, at first you all might think, well, that's really difficult. How are we going to do that? But we just need to understand, just like how the reasoning came in, that a number like 5 is greater than 4, and we could recognize that, well, everywhere to the right of 4, that is where x will be greater than 4. We can do the same thing with y is less than x. So on the line y is equal to x, which is this line, basically every y value is the same as the x value. So I'll have points like 0, 0, 1, 1, minus 1, minus 1, minus 2, etc. Now, where would y be less than x? It all depends on where exactly you will find a y value that is going to be less than the x value. So let's just say, for example, that I chose a random point in my Cartesian plane. Let's say I chose the point, so we'll go to an easy one, like this one, right? Let's just pretend here is minus 2, right? So this is y is minus 2. What is the value of x when y is minus 2? Anybody want to tell me? What do you think the value of x is at y is minus 2? If the point is on the y-axis.
Miss, can you repeat?
Okay.
0. Would it be 0?
Yes, it would be 0. So the question was, if my point is on the y-axis at minus 2, what is the value of x? At the point minus 2, well, where y is minus 2,
0.
x is 0. Excellent. Okay. Now, my question is this. With a point like this, is the value of y less than x. Just give me a minute. I don't know what's going on here. All right. I'll wrap it up here, but I'll save the picture. But I want you all to think about that, and you all could just comment for me later and tell me what you all think is the correct thing. Okay. So yeah, I'm gonna save this now. So think about it. With a point 0 minus 2, is the y value less than x, or is the y value greater than x? And you all could just give me a comment on the post as to what you all think is the answer. Okay, so again, the ghost boy, this ghost. Anyway, you all have a wonderful Friday and have a very good weekend as well. And you all could look out for updates for resources and stuff, all right?
Yes, miss.